March 2016, paper 6. The diagram shows the apparatus used to obtain crystals of calcium chloride from a mixture of solid calcium chloride and solid calcium carbonate. Calcium chloride is soluble in water and calcium carbonate is insoluble. The apparatus, tripod, glass rod or steering rod. Write down the order in which the apparatus should be used in this experiment. Okay. We have two solids that one of them is insoluble in water and the other is soluble. Okay. Calcium chloride, which is soluble, and calcium carbonate, which is insoluble. First of all, we need to add water to both of the solids in order to dissolve one and keep the other as residue. So the first step is step B, because we dissolve the soluble solid. Then we need to remove the insoluble solids. So the second step is step C, by filtration. And then we need to get the soluble solid as powders or as crystals by evaporation or crystallization. So the order of the steps is B, C, A. Name the separation method in C. Of course, when you see the funnel and the filter paper, this is filtration. What has been added to the mixture in B? Of course, water. This is water, since he said that one solid is soluble in water and the other is insoluble. What's the general name given to the liquid in the dish? This is the filtrate. If he asked about the solid, it's the residue. How would you know when you stop heating in dish A? When you reach crystallization point, and you will know that by the glass rod test, or you can even say that some crystals will appear at the edge, but of course, glass rod test is a better answer. Question 2, this is an investigation of the reaction between solution J and K with sulfuric acid at different temperatures, okay? He used a measuring cylinder, which is inaccurate. Notice that when reading the experiment, and he is adding distilled water to sulfuric acid in a 250 centimeter conical flask, and then he's adding an indicator, and then he's adding solution J, okay, to the reaction mixture. And of course, he measures the time taken for the mixture to turn pale yellow while measuring the final volume. He repeats the experiments at different temperatures, and then he asks you to take the readings of the stop clock diagrams, okay? So for experiment 1, it took 128 seconds. The average temperature was 16. To calculate the average, you add the final and the initial over 2. Okay, you add the final to the initial temperature over 2. 58 with 27, 27 with 41, 18 with 50. And then you will draw your smooth line graph. This is the smooth line graph with the points plotted. Of course, it finishes here, but you will extrapolate it because you will need to do that for C. Don't extrapolate like that, okay? It continues at the same rate. The curve goes smooth like it should. From your graph, deduce the time taken, okay? From your graph, deduce the time taken for the mixture to turn pale yellow if experiment was repeated at an average temperature of 60 degrees. Okay, show on the grid, so these lines are worth 1 mark, and the temperature is between 12 to 13 seconds at 60, and the extrapolation is for 1 mark. Question DI. In which experiment was the rate of the reaction the greatest? Of course, it's experiment 4, since it took the least time, 18 seconds. And then he's asking why, because it had the highest temperature, so particles had more energy, and they made more frequent successful collisions. In this March scheme, it was accepted that you just said more energy and so more collisions, but of course, the best answer is more frequent successful collisions. Any two of these get you the 3 mark. EI suggest the 2 marks. EI suggest and explain the effect on the results of using a burette to measure the volume of solution J. Of course, the result will be more accurate than a measuring cylinder. Always compare the burette to a measuring cylinder. That's why he always gives 2 marks on this question. Double I suggest and explain one other improvement to these experiments. The best improvement when dealing with any experiment with temperature measurements is to insulate. Just say insulation to reduce heat loss. You can say add a lid, but insulation is the best. Or you can say that he also should measure the water and the sulfuric acid and the methyl orange using a burette instead of a measuring cylinder. But don't just say use a burette instead of a measuring cylinder. You say use the burette to measure the volumes of water, sulfuric acid, or methyl orange. Okay. Cations and anions. Question 3. 2 M were analyzed, solid copper chloride, and solid M was a different salt. So what is the color of copper chloride? The color of copper chloride is green, also blue is accepted in the mark scheme. B is adding distilled water to this solid and shaking, then he added drops of aqueous ammonia. Take care, this is the observation that comes with the highest number of marks in the table of cations. Ammonia with copper gives pale blue precipitate, which dissolves in excess, soluble in excess, giving deep blue solution. Okay, precipitate is for a mark, blue dissolves, giving deep blue solution. Then double I, excess aqueous sodium hydroxide is added, just pale blue precipitate is enough, even when he added excess, because the precipitate doesn't dissolve in sodium hydroxide. Triple I, he added dilute nitric acid followed by silver nitrate. Since we have chloride, so the result is white precipitate. When he added barium nitrate is the test for sulfate, and we don't have sulfate, so no change. Okay. Here, appearance of the solid is white crystals. You must think that something from group 1, 2, or 3 or zinc is present. Also, ammonium salts are white. Then he heated the solid and the gas given off was tested with damp red litmus paper. A sublimate formed, okay, on the sides of the test tube, and the litmus paper turns blue. When you find litmus paper turning blue from a gas, probably this gas is ammonia, okay? He dissolved solid M in water. He added sodium hydroxide and heated. A pungent gas with a pH of 10 was produced. This definitely is ammonia, and ammonia is produced from ammonium, okay? Or, take care, ammonia is produced from ammonium or nitrate. Those are the two ions that produce ammonia. But if it's produced from nitrate, you must see aluminium foil in the test. If you didn't see aluminium foil, it came from ammonium. Finally, he added silver nitrate, produced yellow PPT, which is exclusive for iodide, so ammonium iodide was the salt. Okay, the final experimental design was chromatography, which is a very easy one. He has an orange drink and he wants to know if the artificial colors E110 and E129 are present or not. He wants you to plan an investigation to show that these were not present in these artificial colors are not present in the orange drink. You can get many marks from the drawing. Writing chromatography takes a mark, the baseline takes a mark, the solvent takes a mark, and the samples like this takes a mark. Okay, so you can say by chromatography, draw the baseline, add the samples, the orange color and the E110 and 129, then dipping the tip of the paper in the solvent for some time. The final mark is very important. You either compare the heights of the spots to prove that the colorings are not in the orange drink, okay? And if you just drew, you must draw the colorings like this. None of the 2 foot colorings should be present in the orange sample. Or you can say measure RF values and compare to standard known RF values. You will measure the RF value of this spot, okay, and you will compare it to the known values of E110 or E129 to prove that they were not present in the orange solution. This was March 2016 by Mr. Marco.